Welcome to Mastering Solutions. For this, we don't have to draw a ray diagram, but we are asked to calculate the image position and the height for the diverging mirror. So to calculate the image position for this mirror, we're going to use the thin lens equation. Now, even though it's a mirror, the thin lens equation still applies, as the book talks about. So the power of a lens, or a mirror in this case, is equal to the inverse of the focal length in meters. That's equal to 1 over the image position plus 1 over the object position. And so we're trying to solve for this. So let's minus over 1 over s. So 1 over s prime is equal to 1 over the focal length minus 1 over the object position. Since it's diverging, the focal length is always going to be negative, like we were talking about. And for this, we're always going to get a virtual image for a diverging mirror. And maybe I'm getting ahead of myself because you'll see that here in a second. 1 over the focal length in meters is negative 0.25 meters. And then we're going to minus 1 over the object distance, which we said is 0.45 meters. So that's going to give us 1 over negative 0.25 minus 1 over a positive 0.45. So we have negative 6.22 diopters, negative 6.22 diopters. And if we take the inverse of a diopter, that gives us meters. So we have negative 16.1, so we'll just call it negative 16 centimeters. So that's where our image is going to form. The negative on a image position, like we were talking about, tells us if it's a real or a virtual image. Negative indicates virtual. So you will always get a virtual image with a diverging mirror. Now to figure out the height, we'll use the magnification equation, which says that m is equal to h prime over h, which is equal to s prime over s, and this side needs to be negative. So we're trying to isolate this, and we have these two and the image height. So let's isolate this by multiplying both sides by h. So we're just taking this section right here. So we have h prime is equal to h times negative s prime over s. So h prime is equal to the object height, which we said is 3 centimeters tall. So 3 times 10 to the negative 2 meters, multiplied by a negative 0.16, so we need another negative 0.16 meters. So this negative value comes from the equation. This negative value comes from our previous answer, so both are necessary here. Obviously, you can see that when you plug that in, you could save time and just keep it as positive, but I'll put it in both for just being really thorough. And then over the object distance, we said was a positive 0.45 meters. So now we have 3 times 10 to the negative 2 multiplied by a negative 0.16, not 5, 6. And then that's divided by positive 0.45. So we have in meters here, and we want 1, 2. So we'll say 1.1 if we round it. So the image height is 1.1 centimeters tall. So with a diverging mirror, you can see that the image is smaller than the object. So we will always get a virtual and an upright image. The positive here indicates that it is upright. If it's a negative here, that indicates it's virtual. And since this is smaller, we did get a little bit of minification, which if you've ever seen a diverging mirror, like in a security camera or like in a mall or something like that, you see that the image is smaller. So here are your two answers for the image position and the image height.